Okay guys, now let's get into Haworth's formula. In case of Haworth's formula, what happens is, it's this cyclized structure. Now I had already explained to you, oxygen of hydroxide of 5th carbon does a nucleophilic attack on this carbon of carbonyl of aldehyde. Alright, and gets cyclized, and this H which is there gets transferred over here, and we call this as anomeric carbon. This carbon was sp2 hybridized, whereas this carbon is sp3 hybridized. Alright, this is planar structure, this is three-dimensional tetrahedral structure. So now since it is a planar structure, so the O can attack carbon from below as well as from top. Suppose this is the carbonyl. Alright, so O can attack from top and O can also attack from base. It can attack from base, at the same time it can also attack from top. Alright, so obviously when O attacks from top, we get one structure, and when O attacks from base, we get another structure. So we have two structures, alpha and beta. Now let us understand what do we mean by alpha and beta. Now in case of alpha, just focus on this OH. Now I presume you are aware about it is this OH. Alright, this OH and O we are talking about. So this OH and O are further away from each other, whereas here this OH and this O is very close to each other. Now we had seen in case of double bond about cis and trans, when on the same side of double bond we call it as cis. So just applies the same theory over here. So this also is cis in a way, and this is trans. So this is cis and this is OA, so it is trans. Alright, now trans we also call it as alpha, and cis we also call it as beta. So we would be calling it as alpha and beta. Now in case if there is confusion between trans and cis, see what I say my kids is TRANS, A is there. So assume that this is alpha there. So trans is alpha. Just a way to keep it in mind. Alright. So we got two structures. Alright. One is alpha, where O and OH are further away, and other one is beta, where O and OH are quite close to each other. Similarly, when we talk in terms of fructose, same is another thing I just forgot to mention over here. Now see, we already had capital L, capital D based on glyceraldehyde. Then we had positive and negative, which was again based on polarimeter. And now we got alpha and beta, which is purely based on arrangement of OH and O. Alright, so similarly now when we come to fructose, fructose also same is the story over here. Now here again this OH we are supposed to check. Now when we compare, we find, I hope you are aware about this OH. This OH is this OH, and this O which is there is this O, 5th carbon oxygen linkage. So it is your 5th carbon oxygen linkage to 2nd carbon. So 5th carbon to oxygen linkage to 2nd carbon, and this OH is this OH, and this CH2OH is this CH2OH. Alright, now since it's a planar structure, so O can attack from below as well as can attack from top, giving you two structures, alpha and beta. Alright, so this is how it works in case of fructose. Let's check it out over here. So in this case we find that this O is away from O, so obviously it is trans. So trans has A, so we call it as alpha. In this case it is very close, so it is cis. So, and cis we call beta. And another thing which I had already mentioned was this forms, glucose forms 6-membered ring, that is pyran, and this forms 5-membered ring. Alright, so that is furan ring. So we call it as In this case, we call it as glucopyranose, fructofuranose. Alright. And these are also called as hemiacetal. Alright. Well, we spoke about everything. What remains is placement of hydroxide when cyclization occurs. When we talk about placement of hydroxide, when the open structure forms the cyclized structure, all the hydroxides which are on right of carbon would go down, whereas one which are on the left would go up. Just to keep in mind, I say that I have spent my lifespan in research and development, doing research. So R and D, keep that in mind. So R for right and D for down. R for right and D for down. So let's check out over here. Now in this case, we are talking of second carbon. The second carbon hydroxide, obviously we cannot consider first carbon, because first carbon we know it can be alpha or beta. First carbon. So we are talking of second carbon. Now when we talk about second carbon, it's in right, so it's down. Then when we come to third carbon, it is towards left, so it is at the top. And again when we come towards fourth carbon, it is towards right, so it is down. And then further, of course, it again is the anomeric carbon, so this CH2H, we are talking of this CH2H. Similarly, when we come to fructose, we also find the same story over here. Now in case of fructose, second carbon we don't consider because that is the anomeric one. Then when, let's just check out the third carbon is towards left, so it is at the top. And again fourth carbon, when we check, it is towards right, so it is down. And again fifth carbon is as it is. Alright, so this is how, if you keep it in mind, if you keep right and down, so while cyclization, placement of hydroxide would be very easy for you. Okay, so this is the formula that you have got to apply for placement of hydroxide after cyclization in Haworth formula. Alright.